Hi, my name is Christian. I am going to talk about scoping microservices, or finding the responsibilities for individual microservices, deciding on what the boundaries for the microservices are. Because that turns out to be quite important in order to get a microservice a microservice system to work well. There are many things that need to go into a system to make them really good, but one of the important ones is really getting these scopes right. If you get them wrong, it just doesn't really work, and you don't get the benefits that you can from the microservices. Much of what's in this presentation, most of it actually, is from my book on microservices, which is a couple of years old now. But still most of it is from there, and then there's a little bit more in the presentation as well, which I guess I've learned since things evolve, right? So let me just turn this on. So first of all, I think we need a little bit of an introduction to what I mean by microservices. I'm not going to spend too much time on this part because all of you have an idea what a microservice is, but putting a few words on this, I think, sets the stage for the rest of it, which is the scoping. Because if we understand what a microservice is and what we want to benefit, what benefits we want from them, it becomes a little bit easier to understand how we find those scopes and how we decide what each microservice should do. So here's a quote. A microservice is a service with one and only one very narrowly focused capability that a remote API exposes to the rest of the system. So that's a quote from my own book, and that's the main reason to write a book, that then you get to quote yourself, as if it's authoritarian and it's the real deal and everything. Anyway, so that's a microservice according to me. And there are a few things to unpack here. So first of all, it's a service. So we are in service-oriented architecture land still. Yes, it is a just a take on SOA. It's not something completely different from that. And so the take is really that it's a very narrowly focused service that deals with just one capability. And we're going to talk some more about what that means. Now, if they're so narrow, there has to be more than one of them, and they have to collaborate in order to do anything interesting, because the systems aren't that narrow. We don't want to deliver just like tiny feature to the end users. They want complete systems. So that's why whatever they do is exposed to the rest of the system. And I use API up here in a broad sense. So that could be like an HTTP API. That could be messages over a queuing system or a bus or whatever, a means of interacting between the services. So let's look at a small example just to get started, and we'll use this example some more throughout the presentation. So if we imagine that we were building, let's say, a backend system for a chain of shops, it could be like 7-Eleven or something, they might have a loyalty program, so the green thing in the middle there. So you get this plastic card, and every time you buy something in the 7-Eleven, they swipe it or whatever, and you get some points, and once you have enough points, you might get a rebate on something, or you get some special offers or something like that. So that might be something for a microservice to handle, that loyalty program bit of what the system needs to do. There's some other bits around it that it collaborates with. So in the top left-hand corner, we have the blue box, special offers microservices says. So that's probably something oriented towards business users. They can go in and say, on Sunday, there's 3 Mars bars for the price of 2 or whatever. And then there's an interaction between the loyalty program and the special offers. Whenever there's a new special offer, maybe that loyalty program wants to notify somebody about it. Maybe it, based on my previous history of buying stuff, they can figure out that, oh, I really love Mars bars, and 4 o'clock Sunday afternoon is a really good time to notify me that I can get cheap Mars bars, so they can sell me something. So there's some interaction going on that we get the special offer entered up here. The loyalty program reacts to that and sends me a notification. And we split this into different parts. Okay, so why would we ever want to do something like that? The main reason, at least when I'm talking to a room of mostly tech people, I guess, in this room, is that it enables continuous delivery. But there's a reasoning behind that, really, which is that, well, why do we want to do continuous delivery? And that's to enable some flexibility, some quick turnaround, give the business the possibility to experiment, to quickly get features out of the door, low time to market, and so on. And I think it turns out that there's a relationship between microservices and continuous delivery where one makes the other easier. So microservices are small, and it's just easier to build all the automation that you need to do continuous delivery for something small than it is for something big. On the other hand, if you try to do microservices without the continuous delivery part, it's going to be really, really difficult because you have so many small moving parts that you have to shepherd around and do stuff with. So you want that automation around it. So there's this back and forth that you probably need to do both. At least if you're doing microservices, you also need the continuous delivery bit. And then together they do deliver on this promise of some really good flexibility, if we get it right. Now, there are some more benefits to this that we might have. We can get some highly maintainable services. Again, if we get them right, they're quite easy to understand. The code isn't that big, so it's an efficient developer workflow, and they're quite maintainable. Of course, we can also shoot ourselves in the foot and write some horrible code that doesn't make any sense and is hard to maintain, but it doesn't have to be that way. And often it isn't, because if we get these scopes right, the services make sense, and we can keep them in our head, and we can actually understand what they're supposed to do. And that reflects in the code, that it becomes understandable. They can be pretty robust by design. Again, there's more to it than just the scoping, but scoping is part of it, that if we get these things split up correctly, then we can get into a situation where it's okay for a little bit of the system to be down. The rest of the system just continues to work, and maybe nobody ever notices. And that's really a strong point, that we don't pull everything down if there is a small problem. So we can really get some robustness in there by design. Of course, this is something that also has a flip side. If we get it wrong, it can just be completely opposite, that it almost never works. So it's quite important to think kind of hard about how do we split these things into the microservices. And again, if we get that right, we also get some flexibility in terms of scalability. So there's the flexibility on the business side of being able to experiment and so on, but there's probably also some hot paths in most systems where most of the traffic or a lot of the traffic come through. And it's really awesome if we can actually scale those parts out without scaling everything out. That's a nice piece of flexibility to have too. So, okay, so that sounds awesome. So why wouldn't we do it? Mainly because it's a distributed system, and it's a very distributed system. So I put hundreds up there. Could be different, but that seems to be what I've seen in the microservice systems I've worked on, at least, that it gets into the hundreds of different microservices for things that make it worthwhile to go with the complexity that comes with microservices. And that's a lot of moving parts. So that's a complex thing to have. It's complex in the production environment. It's lots of deployment, lots of automation around those deployments. So it's definitely not for free. So we want that to be justified, mainly by really wanting that flexibility on the business level. And there should be some inherent complexity in what the system does. Otherwise, this is just adding too much complexity. If you were in the talk about feature toggles earlier in this room, there was, Andy mentioned that, yes, feature toggles also can add some complexity to a system. And I think that's very typical of how we solve things, that we start out with some complexity. Then we add a solution to that, and that adds some other complexity. So we kind of handle complexity with complexity. But I think that's okay, because it's about getting a more manageable set of complexities. But you do have to balance these things. Is the inherent complexity such that we'd rather have the complexities of the hundreds of services? Or is the inherent complexity in the system small enough that maybe just having one thing and keeping it in there is better? That it's a judgment call, but you have to look at that. And then there's this point that refactoring across services is cumbersome, just because you can't really just push the button in your IDE and then move something from one service to another like you can if it's just one big code base. All right. Now, I like to look at microservices as something that has the following 6 characteristics, and I use these characteristics both to guide how I design microservice systems, and also sort of to look at systems that people claim are microservices and say, do I agree or don't I agree? And it doesn't mean that if I don't agree, that's a bad thing. It's just nice to be able to know whether we're talking about the same thing when people say microservices. So the things I use to guide the design and the scopings is, first and foremost, that a microservice is responsible for a single capability. Second, it's individually deployable. That means that we can take just one microservice and deploy a new version of that microservice without having to take down the rest of the system. So we can just switch one thing out. That's quite important for that flexibility. It can consist of more than one process kind of thing. So and that sort of ties into the one before it with the deployability. So you might have situations where, well, let's say you've containerized it, because we all run containers, right? And there might be like a web interface, and there might be some kind of background job. That might be 2 different containers, but logically that can be one service, because it might be the unit that we have to deploy together, and they together handle a capability. They own their own data store, so they come with a database as well. And this one is kind of the one that's about the size of it. That typically a small team, so that could be a Scrum team, of about 5 people, can maintain, well, a handful of services. That's what I set up there, and that's what I've said in the book. But this is one of the places where I kind of disagree a little bit with myself, that it's probably more than that. It's a couple of handfuls of services that a team should be able to handle. And what does that mean? That means that they can bug fix, they can create new features, and so on in all of those services. And of course that depends on how much active development there is. So this is definitely not a precise measure, but turns out to be quite useful. Lastly, microservices tend to expose this feature that they are replaceable. Each of them are sort of small enough that it's possible to handle the workload of actually deleting all the code and just writing them again if we got it wrong. So we got the design wrong, we got the data structures underneath them wrong, we got the schema in the database wrong. We can just do it over because they're not that big. That's a really nice feature that we get as well. But all of these also go the other way around. They also inform how we should design these microservices, because we want them to have these characteristics, otherwise we don't get the benefits of microservices. All right, so the main topic right now was the scoping of the microservices, so we will dive into that now. And the main thing behind that is bounded contexts, which is a domain-driven design concept, which is a subdomain. So we have the big domain, that's everything the system does, and then part of that, a subdomain of that, can be a bounded context. And we can recognize the bounded context for something where the language is consistent. So in many systems and many organizations, words can mean more than one thing depending on where we look at it. So a customer can be different things in different parts of an organization. So there might be a sales department, and for them, maybe a customer is an organization that buys something from our organization, and originally maybe the customer was a lead, and then at some point we signed a contract with them and they turned into a customer. Then we might also have a completely different department that offers support for our products, and for them a customer might be an individual real person calling on the phone and asking to get some help. So it's not just another company, it's a person. That's very different ways to look at what a customer is. Maybe for that support department, maybe it's not so much about whether it's a paying customer. Maybe we have like a freemium model and we actually offer support even to the free users that we have. So for a sales department, they're not customers yet, they're only leads. But for a support department, maybe they are customers. It's the same thing, maybe. That depends on the business decisions, of course. But those are examples of how the language might differ for different parts. And that would mean that sales is a different bounded context than support is. And that tends to follow organizational structure as well. So that can also inform how we find these bounded contexts. Okay, so the next concept is a business capability. And a business capability is something that the business does. And these are things that we do inside of a bounded context. So the sales department converts leads into customers, paying customers. And there's a process around that, and contracts get signed and whatnot. But that's something that they do within that bounded context. It's not done in another bounded context. That's sales. It's not something completely, it's not development, it's not R&D, it's not support, it's not transportation. It's specific to that bounded context. But, also, there's sort of more than one thing going on within a bounded context. We do more than one business thing in there. So there are several capabilities within each bounded context, and they each exist just within the bounded context. And that's what should primarily guide how we scope the microservices. That the primary driver for scoping microservices is business capabilities. So we need to discover these business capabilities through talking to real experts, identifying the bounded context, drilling down further, finding these business capabilities, and then that's what informs that, okay, so we can build a microservice that handles this. So, returning to this example and looking a bit more at that loyalty program that we have in the middle. What should we do in there? I've already mentioned some of it, I think. We probably have these plastic cards, and they need to be issued, and they might get lost, so they probably need to be able to be cancelled as well. We need to award these loyalty points whenever somebody buys something. Maybe we want, for our most loyal customers, maybe sometimes we want to run a raffle and give them a prize just randomly, because they're so good customers. We want to track whether they're eligible for different kinds of special offers, like the Mars bars, or it could be bigger things, like if it's sporting gear, and I like to run, and they may even know that last time I bought running shoes was 1 year ago, so it's probably a good time now to push some good offers for new shoes to me, because maybe they're worn down and so on and so forth. So they can figure those kinds of things out, and they say, oh, he's eligible for this. Now go maybe do this. And for some things, some kinds of organizations might have sort of special events for valued customers. So if you really buy a lot, and 7-Eleven is probably not the best example for this, but if it's a chain of clothing stores, maybe they have sort of opening hours that are only for the loyal customers. So there's 2 hours where the shop is only open for those kind of people. So you do these kinds of things. So we're beginning to see that maybe what I had on the previous slide, which was that the loyalty program was a microservice, maybe that's not entirely true. Maybe the loyalty program is a bounded context, and maybe we have some capabilities within that one. So probably a better picture, a better approximation of where we want to end up with this is something like this, where now it's a loyalty program bounded context, and within that there are several microservices. So each of the gray boxes is a microservice now, and there's a microservice for tracking the loyalty points, a microservice for keeping track of who's eligible for these special offers. And that's not really the same thing. So there's some business logic around when I buy something, how many points do I get? But there's some other business logic that says when there is a special offer, am I eligible for that special offer or not? And so on and so forth. One thing we can notice as well in this picture is that I have a loyalty card microservice, but I had 2 bullets on the previous slide. And sort of when you look at these things and you might map it out something like this, these capabilities, it doesn't mean that it's just completely one-to-one. So there is something around issuing cards and something about canceling cards, but maybe it's just because I've sort of pinned that out. Maybe the capability really is handling cards, and that's why it's in one microservice here. But this is probably still only an approximation of where we want to end up, because I just made this up, right? Well, when I made the slides. And we should talk to real business people, and they should inform this, and you should expect this to evolve over time as well. We get smarter as we go, discover more capabilities, and this picture will grow as we go. Right, so that's the first rule, and that's the first driver for finding these scopes of microservices. The second one is related but different, and it is that the second driver for scoping microservices is technical capabilities. And it's a distant second, but it is a second. And it has to be a distant second, and part of why we have to remember that is, as techies, and that's myself included, we can get caught up in these technical capabilities and focus too much on them instead of the business ones, and that just leads down a road where we really don't deliver on the flexibility to the business in the end. So what's a technical capability? We continue with this example and say that when we figure out that somebody is eligible for a special offer, we want to notify them. But maybe not. Maybe we have several ways of notifying people. So we could have. So that's the guy over there who's in the loyalty program, and maybe if it's me, I want a text message, and if it's somebody else, they want an email, and third person has our mobile app installed and would rather have a push notification, some kind of notification, and the fourth person might never ever want to get notified about anything. We might want to respect that too, right? So there's several ways of sort of dealing with that. So we could do that in that within the loyalty program bounded context we figured out. It still says microservice, but we kind of figured out it was probably a bounded context, right? So we could keep it in there. Or we could say, okay, these are kind of different things. We need to send emails. We need to send text messages. We need to send push notifications. And that's not really something that lies inside of a loyalty program bounded context, because it's not really that subdomain. It's a technical subdomain. So we split that out into microservices. And if we're kind of binding this back to the domain-driven design again, then these also act as anti-corruption layers. Because there's an integration to some third-party system for sending the text messages. There's probably an SNS gateway that we have to talk to there. And that's not something that we want all over our system. Let's isolate it over there. So that's sort of a second driver, that we want these services that handle these technical things. Now, if we look at this picture, there's still something bothering about it, because Now, the loyalty program doesn't know how to send each of these notifications, but it still knows that there are 3 ways of sending notifications, and it still has to decide which one to use. And that kind of pushes us towards maybe there's actually a business need there. So sometimes there's a back and forth between these things, that now we were looking at splitting out some technical capabilities, but that made it a little bit clearer that actually there's also a business capability of notifications, and figuring out that the best way to notify Christian about a special offer is through text messages at 3 o'clock in the afternoon, because that's when his blood sugar is low and it's really easy to make him buy stuff. So we want to tap into that, of course, because we're nice people. So that gets split out, and now that's actually a business capability, and that further removes it from the loyalty program. Now that can abstract it away and just say, we want to notify him of this special offer, and that's it. So there's a back and forth, and you see how these things evolve, and we find these these new microservices and new capabilities, and we shouldn't be afraid of that. And that's also kind of why we need to get really good at continuous delivery in order to do this, because we want to be able to quickly just spin up a new microservice and get it to production. Because if we can't do that, then we'll tend to just, let's just put it into an existing microservice. And then over time, that microservice just becomes the god. And it's its own monolith with the same problems as people tend to want to move away from when they start to do microservices. So, all right. Third rule, and the last rule. So I have 3 that I want you to remember afterwards. The third rule here is that when we think about these scopes for microservices, we should strive to make developers, our developers work efficiently. And that has to do with Conways Law, which states this, that any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. Okay, so that's a mouthful. So that means that if the people over here are a team, and the people over here are a team, and the people at the back is a third team, then we will tend to design systems where if the people at the back and the people over here, they talk a lot, then the components that each of those teams develop will be tighter coupled and will communicate more, will send more messages between each other. And then if the people over here, they're maybe in a different country and we don't talk so much to them, then the same will happen in the system, that they won't really communicate as much. That's kind of turns out to be true, and it's been true for a long while, and I think it's something that we just have to accept and then work with. And we can work with that in several ways. So one way at looking at this is that if we sort of diagram things out like this, we have some boxes and some arrows, and that can mean anything basically. It could be services, or it could be an organizational diagram. And the thing is, with Conway's Law in mind, they are kind of copies of each other. Not exact copies, but they tend to actually look a little bit like each other. So, now, if the arrows are dependencies, if the arrows means that the top one is a service that calls something in that service, and this one needs something from this service, that kind of also means that the team developing this needs something from these guys. And they need something from these guys, who need something from these guys. And now what we're creating here, if we have a deep hierarchy, this is kind of deep, it could be deeper, we're creating a situation where the team at the bottom, they have a really hard time, because every time they can at least have a really hard time, because if they change something, there's a whole chain of things going upwards that depend on them. So maybe they so if we design it in a way where they have to ask, is it okay for me? Can I change this API by now? And what does that mean? Do I pull you down, which means that everything is now down as well? then we've created a situation where the team down here will look really bad and really inefficient. But it's not really their fault. It's because we've made a bad architectural decision. Whereas the people on the top, they have no dependencies. They're just in a completely blissful world where they can change anything and nobody depends on them. They can just do whatever. And it looks like they're really efficient. They're really the top performing team. But it's just because we designed the architecture like that. So it might be equally good teams, really. So that's something to look for. Not creating these chains of dependencies and making these arrows, in a manner of speech, as thin as possible. So making the coupling as low as possible. Often done by having events-based collaboration instead of like synchronous calls between them. Means that things aren't temporally coupled, that we don't call things explicitly, we just put events on a queue, for instance, or a bus. That's usually a lot better in keeping these away from each other. But in order to be able to do that, we can only do that if we look at those scopes and get them right. We follow those business capabilities, but then also look at how our teams actually structured. We have to respect that. And it could go both ways. We can also change the teams, of course, but that's not always a possibility. So it's something to look for. Another way kind of to approach this part of it is to do value stream mapping, sort of for developers or for coders. And the thing is that above the line, it's value creation, and below the line, it's not really adding anything, but time passes. So we can also create situations where these dependencies that we looked at the previous slide means that now the team can just go ahead, they can code, and they can make their unit tests, and they can do blah, 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 and maybe they want to do the unit test first, I don't know. TDD or not, that's up to you. But anyway, if then they hit some wall where, oh, we have a hard dependency on another team and we have to coordinate with them before we know how to design this API, then there's a wait. It might be a short wait. If they're close by each other, like the team over here, the team back there, I said before, maybe they communicate a lot, then maybe it's just getting up from your chair, going to talk to somebody, 5 minutes later you're back. That's not too bad. But it might also be the team in another country, in another time zone. Then you have to schedule a meeting. Then you have to have that call with them, and maybe that's only the next day or next week or something like that. At that point, you're just waiting, and you probably forgot what you were doing when you get back to it, so there's some picking stuff up and doing it again. So if we create these situations where the teams have to interact too much, I'm not saying teams shouldn't interact, but there's such a thing as too much interaction between teams, then we create a situation where we have these waits and they can't work efficiently, and that goes all the way back to the beginning of why would we want to do microservices, and it's in order to provide some flexibility and some quick turnaround. This is not quick. This is waiting, and it's just not quick. So we do really want to respect that people should be able to work efficiently and keep that in mind as well when we find scopes for microservices. Now, the two first ones I could have just put into this rule, so we can make it even shorter, that a microservice should have a single capability, and it kind of actually also takes the last one into account, because if it has more than one capability, then the number of dependencies rises and so on, and that means that we can't really have as efficient work. So it really comes down to looking seriously at only having that one capability. Now, it's also an evolution, as I said, so we can't really get it right, all of it up front. So this is also a rule of thumb that I try to follow, that when in doubt, I'd actually rather have a slightly bigger microservice than a slightly smaller one. And it's because it's just more manageable to have one that's slightly bigger. And it might sound a little bit counterintuitive because it's a micro part of microservices, but don't take that part too seriously. It's really about getting them right. It's not about making them as small as possible. So if we're in doubt, then just let them be a little bit larger, because that means that we can still pretty easily do refactorings. We can move code around. We can get to make new decisions about how we want to design this microservice. And that over time means that we build up some knowledge and maybe get a better understanding of, oh, so there are actually two different capabilities within this thing. Now we understand it. Now we can split it. If we split it up front and get that wrong, we create dependencies, which means that it's slower, less robust. If we put those in different teams, we also create that situation with the wait times. Refactoring is difficult. So it's just the amount of pain that we get from getting it wrong that way is much bigger than the other way around. But there's a balance, of course. I'm not arguing that we should then end up putting everything into just one microservice, which is the whole system at that point. But when in doubt, I'd either err on the side of slightly bigger than slightly smaller. So when it goes wrong, then we have to decide what we can do. And it's kind of simple. We can merge two microservices if they actually handle the same capability, or we can split them, as we just talked a little bit about. And it's an evolution. It happens over time. We get smarter about the system. We figure out how to find those scopes better. So the drivers for merging and the way that you sort of figure out that, oh, maybe this should actually be one microservice, maybe, is often if they're coordinated deploys. So one of the characteristics that I wanted a microservice to have was that it was individually deployable. That means you can take just one microservice, bring it down, deploy a new version of it, and you can just continue. But that doesn't always happen. Sometimes you find yourself in situations where we kind of notice that we tend to deploy these three microservices at the same time, or if we don't, it causes problems. Then they have too much dependency on each other. There's something wrong, and maybe it's just a bad interface we've designed between them, but another possibility is that it's because they're actually handling small little pieces of the same capability, and maybe we actually want to merge them. That's okay. We can also look at what the drivers for splitting a microservice might be. And often that's these two bullets, noticing that many of the changes that we do to a microservice doesn't affect much of the microservice, but it's sort of, they group, so it's sometimes it's this part of the code and sometimes it's this part of the code, and it doesn't really tend to be across those parts of the code. That kind of looks like we have two different components inside of the code base which actually handle different capabilities. So, I mean, again, not a hard and fast rule, but a rule of thumb. Then take a look at it and say, does it make sense to actually split this up? And if it does, yeah, go ahead and do it. It'll be fine. Another thing is if the service becomes big, slow, cumbersome to work with, if like opening your IDE and loading up the code base for the service becomes slow, if running the continuous integration build is like 10 minutes or 20 minutes for a service, there's probably something wrong, right? And that's when these things start to really hamper the efficiency of the developers, and you'll feel that pain. And one of the solutions might be that, okay, we got the scoping wrong, and we need to split the service into different capabilities. So, since I would rather err on the side of slightly bigger than slightly smaller, it means that if I get that bit right, I would more often split services than I would merge them. So let's look at how you actually split them. And this is going to be a little bit quick, but the way you really do it is you identify those sub-capabilities. So you figure out that you had this service called something, I don't know, something within that loyalty program, and it was both counting the loyalty points and figuring out if people were eligible for those special offers. Then but you notice that, oh, it's becoming slow to work with, and most of the changes are either to the business logic around eligibility or the business logic around the points. So looking at that, talking to business people, figuring out, oh, that's because that's two different capabilities. Then we can isolate each of those in the code base. Maybe it's already sort of naturally somewhat isolated, and it's not. This is sort of day-to-day refactoring, right? It's splitting things up into different components within it, in different namespaces, depending on your language. Define an interface between them. Make sure that you actually understand how those two different components within the microservice communicate, because that's going to model how they communicate when you split them for real. Then you get to the difficult part, which is splitting the data. So that's probably existing data in production. So you have to make sure that that's not tangled together, and if it is, then you have to make a slightly longer term plan in order to get the migration that you need in place to split them into different tables. Say if you're in a relational database, that you can then later move to different data stores, so that we still keep the characteristic that each of these databases owns their own data and has their own data store. Another way to look at this is that we can draw it like this, that we have a blue thing, which is a microservice, but it turns out it has kind of the yellow thing and the orange thing, and it's doing different things, and it's just jumbled together in the first step up there. But then we isolate it into different components. Do the same in the database. We sort of make sure that we identify which parts of the database belong to each of them. Then we define an interface, and at this point we're ready to actually split the code bases and deploy them as separate microservices. So to sum this up, I want you to remember 3 things, which is that the primary driver for scoping microservices is business capability. Secondly, they can handle a technical capability. And thirdly, we have to respect Conways Law and make sure that people can work efficiently. Otherwise, we'll lose the game anyway. So thank you for listening, and I can see we have some time for questions if there are any. I'll stick around as well for questions, and you can contact me on these places as well if you think about a question later. But I'll just move out of the light if anybody has a question. This one. Okay, let's start there.
I wonder if every microservice should be replaceable or not.
Whether every microservice should be replaceable or not. So the easy and quick answer is yes, every microservice should be replaceable. In practice, are things perfect? No, they're not. So you don't always get that, but it's something to strive for, that you actually keep them small enough that you can replace them, because it gives you, it's kind of a strong feature that you can actually say, I did this wrong, let's do it over. But I mean, things aren't perfect. Sometimes they get too big, and it's difficult to replace them. But yes, it's something to strive for at least. And yeah.
So, what you can suggest if microservices or more microservices should share a context? So, for example, we have a type. Imagine this enum, and it's used in multiple microservices, not only in one. Should we like extract it to a separate library like Nugget or like in Java, and then reference it in a project, or like move it to the database? What's maybe your approach, or have you faced this?
Yeah, so the question is, if there's something that is shared between the microservices, some kind of a type that is shared between the microservices, then how do you handle that? And well, and you asked specifically, should we move that into a package like a NuGet package or an npm package or something like that? And that's certainly a possibility, and that can work. That makes for some code reuse, which is nice, and we tend to like that. I do want to caution a little bit around that, because it's also a point of coupling if we have that shared package between them. Yeah, so I'm actually not too thrilled about that approach. I have seen it used successfully, so I'm not going to say it doesn't work. But it is a point of coupling where if we want to update the package, then we have to figure out, what are all the microservices that uses this one, and should they then be updated? If it's between two, we might still have the capabilities between them right, but I actually usually would rather just copy it and have the enum or the type in both of them. One of the reasons is Horsdal's law, which says that we should be strict about what we send out, but forgiving about what we take in. So often between these services, we send serializations of objects, right? We send some JSON between them, be it over a queue or be it HTTP request. But there's some JSON being sent back and forth. And if I'm the one producing it, then being strict about that, so not sort of doing it a little bit differently every once in a while. But I can evolve, so I might put more stuff into my JSON object. That's kind of okay. But then the other end should be forgiving about that. If the other end is looking at 2 properties in a JSON object, then look for those 2 if that's what they need. Don't say that I will only accept it if there are exactly these 8 properties, whereof I only use 2. So that's also one reason for not necessarily sharing the objects, but because it can lead you down a road where it's overly restrictive. Yeah, I think in most cases it's more reliable to not share the object exactly. Another thing to look out for if you find yourself in that situation is that, especially if it's not just 2, but it's more, then there's probably something wrong with the capabilities. Because if you sort of need that kind of coupling, it might mean that there's something that we didn't understand about the domain, and we should actually split it in a completely different way and figure out how we get to that stage. I think we have time for one more question. Yeah, so the question is how, when we split these microservices, and from what I said, so I'm going to paraphrase a little bit, probably means that they get smaller and smaller from what I've said here, and that could lead down a road where the interface between these services become really chatty. And the problem with having it chatty is that it makes them more unreliable because there's lots of remote communication, and it tends to be slower. I would say actually the main thing there is around how we design the collaboration. It's also about the scoping, but a big part of it is sort of a different topic, which is the collaboration between them, which I like to think about in terms of 3 things. There's commands, there's queries, and there's events. And if we can get most of the collaboration to be around events, then it doesn't matter as much if it's chatty, because that's asynchronous, and that tends to be much more robust way of designing things. But still, if we have many very, very small events, then there's probably something wrong again. And we might have made them too small. There's such a thing as making them too small. So again, there is some back and forth, but I will say that events can help with this. And I think that's what we have time for. I will stick around if there are more questions. Thank you.